Okay, girls, we've finished up with intramolecular bonding, and now we're into our next type of bonding, intermolecular bonding. Now, we're going to start with our weakest type of intermolecular bonding. We're going to start with these things called dispersion forces. So this is on the page that starts with intermolecular forces. It should be about page 8 of your covalent notes, and it's got the heading intermolecular forces. Now, what are our dot points? You need to understand the shapes of molecules and an explanation of polar versus non-polar. And that's kind of where we are now. We're at this non-polar and polar part. So we've talked about intramolecular forces as being the forces within a molecule. And now we're going to be talking about these intermolecular forces. Now, if you remember, we said something along the lines of intramolecular bonding, very, very strong. Yeah, the sharing of those electrons between those atoms is super attractive. Yeah, so they don't want to break those bonds. But the intermolecular forces are a lot weaker. Okay, and the intermolecular forces are the ones we talk about when we melt or we boil things. So just as a bit of revision back all the way to year 7, we want to think about what is it when a solid turns into a liquid? That's melting. What is it when a liquid turns into a gas? That's boiling. A gas back to a liquid is condensing. And a liquid back into a solid is freezing. Old school year 7 science. All right. Now, what you notice about molecules, about things like hydrogen gas, carbon dioxide gas, oxygen gas, nitrogen gas, you notice that they're all gases. Now, what that means is that their melting point and their boiling points are really, really low. So if we have a look at our first paragraph in our notes, we say when we melt or boil hydrogen, its melting point is minus 259 degrees Celsius. We're not splitting up the molecules of hydrogen. So within here, you have lots and lots of hydrogens that are sharing their electron in the middle there, and they're not separate. Yeah, so when you boil them, they're not separate, they still stay as molecules. So we are simply breaking the bonds between the molecules. So what we're trying to do is we're trying to break apart this bond here, this intermolecular force. As we boil, yeah, we break apart this force. Boiling breaks the force. So the very low melting point of hydrogen, where it's still in our notes, suggests that the forces of attraction between the hydrogen molecules must be very weak. So these forces are very weak. But the forces must exist, otherwise the hydrogen molecules would never stick together to form a solid. So what we do is we make an assumption that these forces are electrostatic. Yeah, so whenever we talk about forces, we're going to talk about them being electrostatic forces. So that's the end of our first paragraph. Now, the next bit is a little bit different. We're going to talk about this concept called an instantaneous dipole. So it's got to do with the fact that electrons at any given time are randomly distributed between both hydrogen atoms at different points in time, and at different times, different parts of the molecule will build up different amounts of charge. So our first sentence says, as electrons are randomly distributed between both H atoms, so we're looking at H2 as an example here. Okay, so as electrons are randomly distributed between both H atoms at different points in time, different parts of the molecule will possess different buildup of charge. For example, when both electrons are located at one end of the molecule, like this one down the bottom here, this end of the molecule becomes slightly more negatively charged than the other end. The end temporarily depleted of the electrons becomes slightly more positively charged. So this could be reversed at the next point in time when the electrons float around and become over here. So now this side is negative and this side is positive. Can you see how that's happening? So it's because electrons constantly move. Now, what we call this phenomenon, this electrons moving, you can see in these top pictures over here, the electrons are at the top. So this side is going to be a bit more negative. This side's going to be a bit more positive. In this case here, they happen to be right in the middle. And this is where you would very, very unlikely, you would get no charge. But because they're constantly moving, these dipoles are constantly changing. They're very weak intermolecular forces, but they are there. Okay, so the molecules are described as having instantaneous dipoles because this is a buildup. The buildup of this charge is temporary. That temporary bit gives us that instantaneous. So at one instant, it's got what we call a pole. So one side is more negative, one side is more positive, but it goes away and then it'll change again straight away. So it's all this movement of these electrons that causes this charge to move around. So the next paragraph underneath that picture talks about the force of attraction between the molecules. So the force of attraction between the molecules is called dispersion forces. Now, it's termed intermolecular bonding. So any kind of attraction there, is termed intermolecular bonding. So intermolecular bonding is an electrostatic force of attraction between a molecule and the molecule adjacent to it or next to it. This type of intermolecular bonding, or the type of intermolecular bonding that is working between these dipoles, these instantaneous dipoles, that is called dispersion forces. So dispersion forces is a type of intermolecular bonding. Okay, and it exists between those instantaneous dipoles. So this is what we call non-directional bonding. Okay, so this is non-directional. Why do we say it's non-directional? Because it's constantly changing. At one moment, you can see that the instantaneous dipole is saying that this is positive and this is negative, but the next time they might change themselves around and they might be negative and negative. And so what we said is this is non-directional bonding because the direction in which it acts changes all the time because of the changing position of these electrons. Now, there's a really important note over there on the side here. This is occurring in all molecules. So whenever you're referring to the types of bonding that are happening, make sure that you always say that the intermolecular bonding that's happening is dispersion forces. Now, there can be other types of intermolecular bonding, but there will also always be dispersion forces. And so that is kind of a little bit of a summary of what dispersion forces are.